Hello guys, so today I'll be showing you how I'll do basically a planning for a client, a sample client in Kitchener, Ontario, Canada. And this sample client I'm working with, I'll assume the name of the client is called Imperial Restaurant. All right, so I'll just say sample Imperial Restaurant. I'm in Canada, so I'll choose Canada. The environment is dependent on the type of client you're doing this for. If it's an airport, a convention center, data center, factory, you get the gist. For me, I'll look for a restaurant, which I'll choose. Project folder is not necessary, but I want to save it in case I ever want to use this Imperial Restaurant customer again. So I'll just save it. All right, once it's saved, just for clarification, the solution I use is called Hamina. There's a couple out there in the market, but the most important ones that are really strong, Hamina, Ekahau, and there's another very low level solution called NetSpot, but it's very low level. Anyways, Hamina, let's get to the point. We want to attach the floor plan. I already have it here, as you can see. So I'll choose the floor plan that I want. It'll take some time. It'll import it into the system. The cool thing that I love about Hamina, although it's not ready yet, but it automatically uses basically the lines that exist in your floor plan. As you can see, it's highlighted in blue. Hamina is able to detect what exactly is a wall, and it'll use basically AI to determine specific properties it'll assign and control the attenuation for your Wi-Fi depending on the type of material you're using. It's pretty cool. In this case, it's already telling that there's walls, etc. And I can show a 3D model of this. So as you can see, the floor plan is showing in 3D, which is super cool. Like, this is awesome. Imagine you're in a meeting with a bunch of stakeholders and you're trying to show them exactly what you're building. Come on. In any case, I'll be doing this in 2D, and I'm just going to change this back to 2D in a second. Just give me 1 second. Okay, so back to 2D. The first thing you always want to do is define your scale. All right, it's very important. Now, if you have the actual coordinates of the location, or the cool thing now some people don't know is, I'll show it to you. If you go to google.com and I choose, let's just say McDonald's, I'll just look for McDonald's near me, open it up in maps. All right, and I just look for McDonald's. Let's just say McDonald's here. Just let's use this building. With Google Maps, you can actually take measurements of buildings. So for example, if I want to measure, let's say this is my client, all right, and I want to measure this building, I simply just need to take, I just simply just need to take the measurement of the building, and it tells me it's 62.84 meters in length. All right, so if I just simply go to Google and I say length to width, meters to feet, my bad, 62.84, that gives me about 200 foot. Now immediately I can already tell that this money part located in Kitchener is about 200 foot in length. Now imagine if you're dealing with a client, you can easily get measurements of their building using Google Maps if you don't have the ability to see the exact building itself. Any case, I already have an estimate of this building. It's about 300 feet. 200 feet in width. All right, the width is about 200 feet. Then if I was measuring in length, the reason you set the scale is because you need to be able to understand how the signal will propagate in the distance. Without a scale to measure that, your entire predicted survey, your everything, your analysis, it's all going to be messed up because the attenuation cannot accommodate for the actual distance. So you have to be very certain you set this. Very important. This is the most important thing in everything. Once you have your skill set, then the next thing are walls. Now, as we mentioned earlier, the beautiful thing with Hamina is it already has the ability to be able to detect a lot of the things it thinks are walls, dry walls, concretes. You get what I mean? Now, I always use the auto draw. This is better because the cool thing is once you choose the auto draw, you can manually delete and move elements that you don't like. And trust me, Amina's auto draw already is somewhat very accurate, except there's little things you need to change. And in most cases, like here, it's just a drywall. So I can say it's a small drywall, very light drywall, just from here to here. That's pretty much it. Look around to see if there's any drywall. A beverage station. This is open. Yeah, that's pretty much everything that I need. Once you've gotten the measurements, or actually you've put in the walls, the next phase is to set the floors. In this case, I only have one floor. I'll probably make another video later showing how to stack it up with different floors, how you can see the bleed through. I'll do a good video about that later on. But for today, we're only focused on a single floor. This is for people that just want to see the immediate solution. Once you've done that, you can set attenuation objects. Now, attenuation objects are things that can affect how the signal propagates in an area. In this case, let's imagine this is a big open area, right? And we can somewhat imagine that there will be a large density of humans around this area. Let's just imagine. So if we know there will be a large density of human around this area, we just need to choose what type of attenuation we're trying to define. Or if it doesn't exist here, the beautiful thing is you can actually add your own custom attenuation, which is awesome. So maybe there's a type of material that you use in your business or something that does not exist here. You can set what but you still need to do your research, but you can set an estimate of what the attenuation will be for that type of material. In this case, I know it's humans. All right, this place is going to be heavily dense with humans, so I can just pretty much set this location as heavy with humans. I can maybe adjust it a bit more, just in the center, probably the bar. The bar is probably where you have the most human. All right, and here it'll probably be this dining hall around here. Okay, and the private dining, let's say in the center, this is where you have the most human traffic. Once you have those elements in, the next thing you need to do is, gauge what areas you think, okay, I don't need to really worry about. These are areas you don't want to concern yourself with Wi-Fi coverage. For example, let's say in this entire space, the backside of this storage, I don't really need to concern myself with Wi-Fi. I can put that as an out of scope zone. If this zone is very important, I put it as an in scope zone. All right. What other area? The dry storage. Walk-in cooler. Yeah, I'll say probably this dry storage somewhere around back here. It's up to you. For me, I'll just leave it. Just for this tutorial, let's just leave it because I don't want it to get messy. It's just easier when I explain the entire video with this. Perhaps I'll make another video showing how you can utilize attenuation objects to control the signal that you propagate in the building. But for today, let's just focus on a simple, okay, we know we need everything on this floor plan. The next thing is the capacity zone. This is just you defining, okay, how many users do you imagine this area should be able to accommodate, and the maximum. For me, I want to be able to accommodate 100 iPhones. It's a big area, and I want at least 10 devices. It doesn't have to be a MacBook, honestly. It can just be a Windows laptop, but I'll just use a MacBook because why not? Once you've defined your zone, you can start highlighting that zone. For me, it's this entire area. Now, one thing you should know is you can change how you actually do this edit. If I actually want to change it, I believe it's this method. No, if I'm not mistaken, it's this. Okay, let's leave it for now. In any case, we want to highlight the capacity for the area. Let's say the capacity is 100, which we've defined. I'm just going to highlight the 100. Okay. I know another about 100 people will be around here as well. And about 100 people will be around here as well. Okay, we've defined the walls, we've defined the areas that would be in scope or out of scope, attenuation points, where humans would be. You could also define more attenuation here if you'd like dishwashing, washing machine would be around here, cooking line, maybe you have microwaves around here. There's a whole cool stuff you can add, but I'm just going to be summarizing this and trying to go through the video. The main point that we want to get to is then the access points. Most of the access point deployment I use is ceiling. Now, in some areas you would use a wall, like these corners, you could use a wall. This corner, you could use a wall. But for me, I just use a ceiling because you can have it in the center. In this case, I can have one AP here. All right. I can have another AP around here. I'm just going to be putting APs here. I think one AP should be around here. One AP should be around here. And another AP should be around here. And I think that's pretty much it. We honestly don't need a lot in this building. Yeah, one AP here. Okay. We can also add one more AP right here, actually, just in the hallway, near the exits. We can have two APs, one here, one there, one here, one here. And we'll move this down a little bit closer to the door. So once our guests come in, they already start connecting to the AP. And we'll have this just a little bit below and right here, just the placement. Now, typically the ceiling height, I always assume it's 15. Some places can be less. You can have 15, you can have 12. It's just dependent. So I want to make sure I have that into account because the ceiling height affects the AP propagation as well. So just make sure you have that in. I should have put that in before. You know what? Actually, let me take this out. I rushed it. I'm going to take this out. All right, I'll select the access point I want. I'm first going to design the access point that I'll be using, obviously. So it's Wi-Fi. You can put 4G antenna, depends on what you're using. For my client, in this case, I'm using Fortinet. Fortinet has a 40 AP. But there's a whole bunch of access points you can choose from. Juniper, Meraki, TP-Link, Ubiquiti. There's a whole bunch of them. But for now, I'll use, let's say I use Ubiquiti actually. Let me do Ubiquiti. Why not? I'll look for the U7. I've used the U7 Lite model before. The ceiling is about 15 feet. I want to define that. I always have my 5 gigahertz around 15 dBm. I think 15 dBm is very good for performance. 2.4 gigahertz, 7 dBm max is fine. It's not a big deal. I always prefer my clients to go for 5 gigahertz. Once we've defined that, the next thing is to start placing the APs. Now, this part is important where it tells you power allocation. Depending on your switch model, because you also have to consider PoE. If your switch has a specific type of model, then this would be very important. If your switch only supports maybe 8 PoE, 4 PoE, 10 PoE, even if your switch supports 20 PoEs, but the actual PoE allocation budget for your switch is maybe 200, and you're using APs that require 20 watts, that means you can only support 10 APs maximum in operation. So you have to be very careful to understand how much wattage your switch uses, how much watt your AP requirement requires, how many PoE ports are available. There are also a bunch of things you have to be concerned about. So just make sure you pick and choose exactly what matters to you. In this case, for me, I think 13 watts is kind of high. Most APs would operate around 7. Well, technically, max some AP their max operation will be around 15, but their day-to-day operation will be somewhere around 7 because it's based on client requirements as well. But let's play it safe. Let's assume it's 13. Let's keep the default. All right, just play it safe. I'll place the APs on the floor plan now. So I'm just gonna be placing the APs in general areas. I'll place one there. I want one in the center. Actually, the center should move a bit closer here. I want one here. Right here. Okay. I think this is it. Then obviously you want to name the APs. So I'll name this guy Main Lounge. All right. And if you have multiple floors, you can say like, if let's say if this is the first floor, I usually do AP F1. This can work. That way you know is AP first floor main lounge. Or you can do location name. Let's imagine this location is Imperial. So I'll say IMPAP F1. So it's all dependent on you, whatever naming standard you think it's easier for you to accommodate. For me, I know this is one floor, so I don't need to go crazy. I'll just call this Grand. My caps is on. Grand Dining. This one is Private Dining. All right. This one is Hallway Easts. You can use Hallway Right if that makes sense for you, or you can use Hallway East. I prefer using the geography because depending on where you're facing, your right and left can change, but regardless, your east and west doesn't change. So I'll use Hallway West for this guy. Right here, this would be a kitchen, so I'll call this kitchen. And this would be admin area, so I'll call this admin area. That places basically all my APs. Now, the good thing is, if this was a more complex environment, I would still work around this. I would attenuate it, change things. Like if it's an environment, it's the production facility, manufacturing facility. If it was a warehouse with a bunch of racks, depending on the environment, what you're seeing and the result will change. But because I'm just showing a sample, this is easier to work with. That's why. Now, the most important thing that I like the most with this solution, this is the best part of it, is client view. You can actually simulate a client. Let's say now a client comes into your business. This is your entrance. Boom, you know all clients would connect to the grand dining hall because that's the actual AP closest to most of your clients in the entrance. So your clients come into the entrance, maybe they have to go into the check-in lounge first. They wait. So in the lounge, your clients are going to be connecting to the main dining hall. Once they have their schedule set, the receptionist says, okay, come in, your table is ready, you're in the private dining hall. They walk in, boom, they connect to the private dining hall. Now, let's say they need to go use the washroom. All right, boom. And then they go into the women's washroom. Well, the women's washroom will be connecting to the private dining hall. The men's washroom will be connecting to the grand dining hall. Let's say they go to the lounge. You can now see a problem. This phone is still sticking. So it means the grand dining hall is going to be sticking a lot of devices when your maybe your guests they come into your building. As you can see, it's still sticking. Oh my God, it's still sticking. Now, this is where you start using different things like QoS policy. You start applying DBM powers. You need to do AP handoff. Depending on the type of controller you use, you can actually set the limit of distance between each client and look for the best APs. So that's why it's always good to not only rely on this, you also need to know how to design the wireless infrastructure as well. But this just gives you a sample. Now, if the client goes too far away, obviously they connect to the nearest, which is the lounge AP. Let's say they go to the back. Boom, you can see they're still connecting. They're still connecting now. They changed. So this just gives you a general idea how your clients will roam. You can see a problem here. This client is all the way back here and they're still sticking to this AP. Now, typically they will roam. Most phones are very intelligent and they roam. But still, this just shows you the worst case scenario so you're aware. Even when you go to the admin area, depending on how thick the wall are. Now, this is dependent on also how the attenuation works in that space. Remember, this space is a lot of drywall. Imagine this was concrete or, there's a different type of material. This will also change. So what you're seeing right now is just because we have a lot of drywalls. In any case, this is pretty much it. This is just a simple overview that I wanted to present. If you wanted to see this in 3D, let's imagine you want to show it to your client in 3D. Boom. Now your client can actually see in 3D what happens. Okay, when they, for example, go to the kitchen. Let's say, oh, what happens when I go into the kitchen? You can show it to them. Okay, you walk in here, you go into the kitchen, and then when you go all the way to the back, you see they're still connected to that AP. Okay, when they go over here, what if I go to the loading bay? Boom, boom, boom. Okay, then they connect to this AP. You can genuinely see how the users roam in your entire facility. Very impressive. In any case, this is just a sample. There's a whole bunch of videos out there about this solution if you want to see it. But another cool thing is the reports. This is where you're able to then generate reports for your client or show them what they need to see. I don't use 6 gigahertz. I don't really have any need for it. Sample Imperial. Or let's say Imperial Restaurant Canada. Alright. Then I choose what I want, simulation or a survey. For me, I'll just do simulation because I didn't do any active survey in the building yet. So I'll just do a simulation. If I did a survey in the building, then I also want to add the simulation survey. The good thing with this report is it also presents a bill of material. It includes the amount of Unify APs we need to get, Ubiquity, sorry, the ceiling mounts. If I had like network rack switches, I can design the entire network infrastructure, switches, AP, cameras, CCTV, whatever the customer requires. It's pretty naughty if I do say so myself. Anyways, that's the end of the video. I know it's a bit rushed, but I hope to put out more information about the solution that I use and what I do for people. If you found this useful, don't forget to follow, like, subscribe. Let me know if this interested you in any way or if there's something about this solution that piqued your interest. Anyways, thank you guys for watching. For those that stuck around, take care. Bye-bye.